Hello students, welcome to video lesson 9.3. We are starting our book work with chapter 9 now here in section 3. We talked in our last video, our intro video, just about what the graphs of quadratic equations looks like. We talked about parabolas and the vertex and things like that. In this video, we're going to start solving quadratic equations, okay? We talked in chapter 8 a lot about quadratic expressions, where we were just trying to factor, expressions that involved x squared, something like x squared plus 4x plus 7 or whatever, okay? Expressions that involve quadratics. In chapter 9, we're going to start looking at equations, which means we're going to have quadratic expressions, but they're going to be equal to something, okay? Quadratic expressions that are equal to something. And our goal today is to begin to talk about how we would solve those equations, okay? How do we solve quadratic equations? How is it the same? How is it different, maybe from solving equations that we have done before? Okay, so remember that when you are solving equations, you're being asked to get the variable alone, okay? Your answers for almost all of the problems in chapter 9, okay? I'm not gonna say all of them, but most of them, pretty much all of them, they're gonna end by you saying x equals something, x equals 3, or x equals -5, or x equals something, or m equals something, or a equals something, or k equals something, okay? So we're getting variables by themselves. We're saying they are equal to a certain value, okay? That's what it means to solve an equation. So that's what we're going to be doing in chapter 9. That's what we're going to be doing today, okay? When the variable that you're trying to solve for, that you're trying to get all by itself, shows up only one time, okay, when there's only one variable in the equation, the strategy should be to undo things and do sort of the opposite operations and things like that, which is the way we've been solving equations since the very beginning of this class, okay? Since chapter 2 and even back in middle school when you were solving equations, you were using this sort of strategy, okay? So for example, just an equation that we've seen a long time ago that we should be able to solve. Here it says 4x plus 3 equals 15, right? So we're trying to get x by itself, so we first have to undo the plus 3 by minusing 3, and then we get 12, and the plus 3 is gone, and the other side says 4x now, and then we divide away the 4, and we get x equals 3, right? So that's our answer, x equals 3 for this equation. In this one, we have to undo the 2 first, right? Or we can distribute the 2 in here. So we get, 2x minus 14 is equal to 12. So then we plus 14 to get rid of the minus 14. And we get 2x is equal to 26. Divide away the 2. We get x is equal to 13 in this case. Okay, so this is solving equations. When the variable just shows up one time, this is our strategy. Look at what is happening to the variable, right? Is it being added to something? Is it being multiplied by something? Is it, what's happening to the variable? And undo those things by doing the opposite operations. So that's the first type of quadratic equation that we're going to look at as well, okay? When quadratic equations have only that one variable, we are going to use exactly the same strategy, okay? But one of our steps is going to be to square root both sides of our equation in order to find our solutions, or in order to solve the equation, okay? Because when we have an equation like this, right, here it says x squared, okay? X squared is equal to 16. And I really want to know what is x equal to, right? What is x equal to? So I need to unsquare the variable. So I have to do the opposite of squaring something, right? The opposite of squaring something, raising it to the second power, is to square root it. So square rooting is the opposite of squaring. So what I do is I just square root this left-hand side, and then I square root this right-hand side. I square root both sides of the equation, right? Up here, we were maybe adding some number to both sides or maybe dividing both sides by something. So again, we're doing the same sort of strategy. What can we do on both sides that will undo what's been done to the variable? In this particular case, we have to undo the x squared. So we're going to square root both sides of the equation. Because the square root of x squared is equal to x, right? The square root and the squared, they cancel each other out. So that's gone. This is gone. It just says x. The other side says the square root of 16. Now, it's important to remember when we're solving quadratic equations that when we do it with square roots, we have a positive and a negative version, okay? So this, the square root of 16 is 4, but the square root of 16 is also negative 4, okay? Positive 4 and negative 4 are both answers to that equation, right? Now, in our last video, we showed you the graph of an equation, right? So let me just say that this equation here would look something like this. I would have this, and way down here I would have my vertex, and then it would come up like this, and then it would come up like this. Okay, so this graph of this particular equation, x squared equals 16, also known as x squared minus 16 equals 0. We'll get into this in a second about equaling 0, actually in our next video. The graph of this looks like this. And remember that we said before, the solutions to the equation are the x-intercepts of the graph. They are the points where the function, the graph of the function crosses the x-axis. So right over here, this would be x equals 4. Okay, and this one over here would be x equals negative 4. Okay, and those two x-intercepts are exactly the solutions to the equation, okay? So your book in this section does some of these solving equations by making the graphs and looking at where they cross the x-intercepts, where they cross the x-axis. But we're gonna do it just by square roots, okay? Just algebraically, using our algebra skills to unsquare things and get things all by themselves, all right? Sometimes we do have to do a little bit more work, though, before we get to unsquare things. So if we look at this next equation, it says 3x squared minus 48 is equal to 0. So I'm, again, trying to solve for the variable x. Okay, so in the end, I want my answer to say x equals something, okay? By the way, in your homework, when you turn it in, for every answer that you solve an equation, I want to see x equals this. X equals this. It's very important so that you show me what variable you're solving for and that you have solved for a variable, okay? So in this equation, I have to undo some things before I can unsquare things. So it's important to always get x squared, whoops, that's supposed to say t, get x squared alone. Okay, just like when we were getting x alone up here. Okay, so in this particular example, I'm going to first undo this minus 48. I'm going to plus 48 on both sides. Okay, plus 48. I'm going to get 3x squared is equal to, this is now gone. This side, 0 plus 48 is 48. I'm going to divide away the 3, right? And so then this side just says x squared. And then 48 divided by 3 is 16. And now I'm actually back to where I was over here with this first equation, right? I have the x squared all alone. So I need to unsquare both sides of the equation so that I can find x. X is equal to, what's the square root of 16 again? Well, it's positive and it's negative 4, okay? And one way that we can write that simply is to use what they call a plus minus symbol. So it's a plus sign on top of a minus sign, and then we can put the number 4. Okay, so that's a perfectly acceptable way to do this if it's just the positive and negative version of the same number, okay? So let's look at another couple examples here of just ways that we might be able to use square rooting to solve quadratic equations, right? So here I have an example, x squared plus 64 equals 0. So again, I'm going to have to do one thing before I get to unsquare. Right? I'm trying to get x squared by itself, and right now it's plus to 64. So if I minus the 64 over to the other side, 0 minus 64 is negative 64. And then the other side of my equation, now that this is gone, just says x squared. So I'm ready in this case now, x squared is alone. I can unsquare that side, and I can unsquare this side, and I get x equals, what is the square root of negative 64? The square root of negative 64 is, let's see, oh wait, we aren't allowed to do that, are we? We can't do the square root of negative 64, and I can prove it to you on the calculator. If I do the square root of negative 64, I get a domain error, right? A domain error when I square root negative 64. Because remember, I'm not allowed to square root a negative number because they don't exist, right? There is no number that when I multiply it by itself is going to give me negative 64. So when I get to this point, I should just scribble out this x equals, okay? And here's what we're going to say. We're going to say there is no solution. There is no solution. Technically, we should say there is no real solution. Okay, that's an Algebra 2 thing, but there's no real solution, or there's no solutions to this particular equation, right? And the reason for that, if I just think back to what we did in our intro video with these graphs, this equation, if I were to make its graph, is actually going to start up here on the y-axis, actually up at positive 64, so like way up there. And then it's going to do this. Okay, it's going to do that. It's going to do that. And it's going to go up forever on both sides. Okay? And that particular graph is never going to cross the x-axis, right? And remember, the solutions to the quadratic equation are the points where we cross this x-axis right here, right? Where do I cross the x-axis? This graph never does. So there is no solution, and we say no real solution. No real number solution is what that means. So when you are square rooting, if you are ever asked to square root a negative, right, or you end up with x squared equaling a negative, we just say no solution or no real solution, okay? So that you're going to see in your practice problems, okay? So this last example is actually one where we have x plus 2 in parentheses being squared. So this is one where, like, I know we said we want to get x squared all alone, but in this case, we have what's being squared already alone, right? It's x plus 2. All of that is being squared. And this is already alone, so I can simply go ahead and unsquare this side and unsquare this side, and I get this. X plus 2 is equal to 5, right? Because the square root of 25 is 5. But the square root of 25 could also be negative 5. So it also says x plus 2 equals negative 5. And now I have just a little bit more work that I need to do to solve this equation for x. So I need to then minus 2 on both sides of this equation, and I get x equals 5 minus 2 is 3, right? I need to minus 2 on both sides of this other equation, right? The other one that came from my negative 5 option when I unsquared the 25. So again, the 2's go away, and it just says x equals negative 5 minus 2 more. Negative 5, take away 2 more is negative 7. Okay, so this is an example where I get two different solutions, but they're not like the positive and negative version of the same number. Okay, because I had to do something extra after I unsquared the 25. All right? If you have any questions at all about solving quadratic equations with square rooting, please reach out to me and let me know. If any of these examples didn't make sense, let me know. Send me an email. I'll try to re-explain for you somehow. Otherwise, that's all I have for you right now, and we'll talk to you soon.